Throughout this course, you'll explore the science of composting, a sustainable process that turns organic waste into nutrient-rich soil. Whether you're a beginner, a farmer, or an industry professional, you'll find valuable insights to enhance your composting practices. Join us on this journey and empower yourself. Let's get started. At the end of this course, you will learn key principles of composting, various composting methods, the skills in crafting well-balanced compost recipes, how to identify and address common issues, insight into the versatile applications of compost, and the environmental benefits it offers. This course is comprised of 5 modules. You will be required to review all 5 modules over the next 3 weeks. At the end of this course, to receive your certificate, you will be required to complete the assessments utilizing the content you have learned. The following modules will be covered. Module 1, Introduction to Compost Making. Module 2, Composting at Home. Module 3, Farm-Focused Composting. Module 4, Industrial Composting. Module 5, Harvesting the Fruits of Composting, Putting Knowledge into Practice. Good luck! Module 1, Introduction to Compost Making. In this section, we will cover the following subtopics. What is composting? Composting ingredients. Composting process. Composting techniques. Troubleshooting compost. And benefits of compost. Let's explore the concept of composting. Composting is the process of recycling organic matter, such as leaves and food scraps, into a valuable fertilizer that can enrich soil and plants. It speeds up the process by providing an ideal environment for bacteria, fungi, and other decomposing organisms, such as worms and nematodes, to do their work. The resulting decomposed matter, which often ends up looking like fertile garden soil, is called compost. Now let's examine the essential ingredients for successful composting and discover how they contribute to creating healthy, vibrant soil. Composting is a process that uses organic materials as raw materials. The key to good composting is to have a variety of materials and a balanced carbon to nitrogen ratio. Carbon serves as the energy source for microbes, while nitrogen is essential for protein production within these microorganisms. Here are some materials that are generally used in the composting process. Brown organic matter, green organic matter, water, good microbes, and oxygen. For optimal composting, ensure a balanced carbon to nitrogen ratio, 25:1 to 45:1, by mixing materials accordingly. Green. Nitrogen-rich material like grass clippings and food scraps speed up decomposition, while brown, carbon-rich materials such as leaves and straw enhance texture and moisture retention. Let's consider additional factors necessary for effective composting. 1. Water. Water is essential for microorganisms in compost heaps to thrive. Too dry conditions reduce their activity, while overly wet environments favor anaerobic organisms. Compost piles ideally maintain a moisture level between 40% and 60%, feeling slightly moist to the touch, but not excessively wet. 2. Good microbes. Fungi, including molds and yeasts, decompose complex plant structures in compost. By breaking down tough materials, they facilitate further decomposition by bacteria, which generate heat and primarily decompose simpler compounds in compost. 3. Air oxygen. Turning the compost pile aerates it, crucial for the microbes that convert organic matter into compost. Insufficient oxygen favors anaerobic bacteria. Ideally, the heap should maintain oxygen levels between 10% and 14%. Understanding the items to avoid in your compost bin is crucial. These includes meat or fish products, slow to decompose, and attracts pests. Dairy product, example butter, cheese, mayonnaise, salad dressing, milk, yogurt, sour cream. These would smell, take a long time to decompose, and attract pests. Oils, grease, or fats of any type, slow to decompose, will putrefy, smell bad, and will attract pests. Glossy paper. The inks are usually toxic and contain heavy metals, dyes, and pigments. Chemically treated wood products. Charcoal and briquettes contain sulfur and other chemicals that are toxic to soil plants. Diseased plants. Weeds with seeds. Heavy metals, lead, mercury. Human and pet animal feces may contain pathogenic bacteria, viruses, and parasites. Let's explore the composting process. Preparation: collect diverse organic materials such as food scraps, dried leaves, grass trimmings, etc. The materials you use should be chopped or chipped into small pieces to speed up decomposition. Layering: place the organic waste in a compost bin or pile, alternating between green materials, like food scraps, and brown materials, like dried leaves. Moistening: add water to the pile to keep it damp, like a wrung-out sponge. Turning: periodically turn or mix the compost pile to aerate it and speed up decomposition. Decomposition: over time, organic materials are broken down into compost by microorganisms in the presence of oxygen, releasing heat as a byproduct. Use a compost thermometer or simply feeling the temperature with your hand to monitor the temperature of the pile. Maturation: allow the compost pile to mature over time. During this stage, microbial activity slows down, and the compost gradually stabilizes. After several weeks to months, the compost matures into a dark, crumbly substance that resembles soil. Harvesting and use: the compost is ready to use when it is significantly reduced in size. It is no longer hot. It appears brownish to black. It has a crumbly appearance. By following these steps, you can effectively compost organic materials and create nutrient-rich compost for your needs. Let's explore some common composting techniques to effectively manage organic waste and create nutrient-rich compost. Indoor composting uses specialized bins or containers for composting organic waste inside the home. Kitchen scraps, shredded paper, or dry leaves are collected to maintain a balanced carbon to nitrogen ratio. Regular mixing provides oxygen to microorganisms, facilitating aerobic composting. Odor-free and compact bins are suitable for apartment dwellers or those with limited outdoor space. Bin or pile composting involves placing organic waste in a designated bin or pile. Green materials like food scraps and grass clippings are alternated with brown materials such as dried leaves or straw. Occasional turning or mixing aerates the pile and maintains high temperatures. Windrow composting involves forming long rows or windrows of organic waste in an open area. Green materials, like kitchen scraps and yard trimmings, are mixed with brown materials such as leaves or wood chips. This method promotes efficient decomposition by generating heat in the long rows. Periodic turning or aerating provides oxygen to microorganisms responsible for decomposition. Vermicomposting uses worms to break down organic waste into nutrient-rich compost. Special bins or containers filled with bedding materials like shredded paper or cardboard, along with kitchen scraps, are introduced to worms like African night crawlers. The worms feed on the organic waste, converting it into castings, or worm poop, which serves as a valuable fertilizer. Each composting method has its advantages and is suitable for different situations. The slide you're viewing highlights various composting challenges and potential solutions. Compost serves multiple purposes. Top dressing. It is applied to the surface of soil where plants grow, serving as a protective and nourishing layer. Soil amendment. Compost enriches the soil by improving its structure, water retention capacity, and nutrient content. pH balance. It helps maintain the optimal pH level for plant growth, promoting healthier and more resilient plants. Versatile use. Compost can be applied to various areas including lawns, trees, shrubs, vegetable gardens, and potted plants, providing benefits across different types of planting environment. Compost offers a multitude of benefits, enhancing soil structure and promoting water retention and slow nutrient release. Acting as a natural mulch, it suppresses weed growth and reduces soil erosion. Moreover, compost sustains the intricate soil web, fostering a healthy ecosystem underground. Additionally, it plays a vital role in carbon sequestration, locking carbon into the soil and aiding in mitigating climate change.